I'm just going to do these in order, starting top left, and same way we did them in class. Top left, top right, and then down. So across and down. So first one, and I'll have the answer in the upper right there. So if you got it right and you feel okay, just fast forward to to the next question. So the first question was 125. You will need to evaluate, right? Any known number to a power that you get. It's not going to be huge, but it's not going to be 4 squared either. Okay, so I've got 5 to the 6th times 5 to the negative 2 times 5 to the negative 1. Okay, so the product rule said we add exponents, number of the same base. 5 is the same, right? 5 and 5 and 5. So I'm going to add exponents. It's going to be 6. If you want, you could write plus negative 2 and plus negative 1. I probably wouldn't do that. I would just go ahead and write it as minus. So minus 2 minus 1. 6 minus 2 minus 1 is going to be 5 cubed. So that's 5 times 5 times 5. 25 times 5 is 125. Second question ended up being 1 over x to the 14th power. Remember, simplified means no negative exponents. Okay, no negative exponents. So make sure if you have a negative exponent that you don't stop. You take the reciprocal. You move it up if it's in the denominator. You move it down if it's in the numerator. So this is power to a power, right? So that's going to be x 7 times negative 2. That's x to the negative 14. And so because I have that negative right there, I'm just going to take the reciprocal. When I do that, I change the sign of the exponent. Please remember, this exponent's sign does not change the sign of the number. It is not negative x, right? So be careful with that. I know a few people did that today on the practice. The next one, the value of this is 1, right? Be a little bit careful, but you see that 0 right there? We know that anything to the 0 power is 1. Any number to the 0 power is 1. So x to the 7 times negative 2, right, to the 0. Well, you know what? Honestly, I'm going to stop because it doesn't matter what's inside of here because I've got the 0 power. Make sure, though, that the 0 power applies to everything, right? So it applies to all of this. If I had something out here, then it wouldn't be just 1 anymore. I'd have to multiply that number by whatever I get. But I don't have anything out there, and so it's just going to be 1, right? This inside, that would be x to the negative 14. Yes, that's true, but it's to the 0 power. Okay, 0 times 14 is 0. Or negative 14, actually. Doesn't really matter, though, does it? So, next one works out to be 625. So I've got 5 to the 6th divided by 5 squared. So, product rule extended into division. Tells me when I'm dividing numbers of the same base, again, I've got the same base, 5 and 5, okay, and so I subtract 6 minus 2, 5 to the 4th, so that's going to be 5 times 5 times 5 times 5. That's 25 times 5 times 5. And we know from before that's 125. And so multiply 125 times 5. Right? 5 times 100 is 100. 5 times 20 is another 100. And 5 times 5 is 25. So 625. Now we started getting a little more complicated. right? And we have the rational exponents. So, and negative exponent also. So there's several things going on with this one. Like I said, you're going to want to, if you have parentheses, you're going to want to simplify whatever you have in here first. That way you don't have to worry about what this is going to do quite so much. You have less to deal with. In this case, though, there's nothing I can do on the inside because the 16 and the 25, they don't simplify. No common factors there. And that's a z and an x. So they're not going to simplify. So my next step is to evaluate the negative, right? That's the way I do it. You don't have to. You could do the square root and then do the reciprocal. Order doesn't matter in that aspect. So anyway, so I'm going to rewrite it, getting rid of the negative exponent on the outside. So now the 16 x to the 8th is in the denominator, and sorry, that's z to the 4th. 16 z to the 4th, and I have 25 x to the 8th, right? This 1/2 power applies to everything inside. All of that, all of that. So that's how I end up here. Now I still have the 1/2, it's just not negative. Don't change the sign of the 25 or the 16. That's not what that negative up there means. So now 1/2, x to the 1/2 is the same thing as the square root of x, right? So now I can take the square root of 25, and that's going to be 5, right? I can just use the power to a power rule, 1/2 times 8, right? It's x to the 8 to the 1/2, so I multiply 1/2 times 8. So that's x4, and 1/2 times this 4 is going to be z2, and the square root of 16, I hope you know, is 4. So that's how I ended up there. Similar problem, except that I don't have the negative up here now, but I do have a negative on the inside. I can take care of that first or later. In this case, it's not going to make a big deal one way or the other. I'm just going to go ahead and evaluate the exponent. So now I've got the square root of 25, right? Square root of 25 is 5. When I'm using it on variables, I just use the power to a power rule. So it's going to be 1/2 times -6 is -3, so I've got x to the -3, so I'm going to have to finish that. And then I've got 1/2 times 2, right? So 1/2 times 2, 2's cancel, and you get 1. So y to the first, but, right, we've got this nasty fellow right there. So I'm going to take that, put it in the denominator, make the exponent positive, write the y on top, and leave the 1. Skip the 1. I won't mark it wrong if you put the 1, but you need to follow normal procedure in terms of the way that you write things. So really you shouldn't. -11. Negative's on the inside. So it is -11 to the 1/3. You know what? I don't know what the cube root of -11 is. And I don't really care because I'm cubing it. So it's -11, right? So the 1/3 power, but I'm multiplying it 3 times, right? So you can do it this way and say it's cubed. There's a product rule, and that's 3 times 1/3, the power to power rule, which equals 1. So then it becomes -11 to the 1. And officially, we should have it like this, but it really isn't going to matter, right? When it's to the first power, -11 to the 1 is -11. That's not exactly how we did it in class today. So in class today, we did it just using the product rule. It's -11 and numbers of the same base being multiplied, so it was 1/3 plus 1/3 plus 1/3. Well, that's 3/3, which is 1. So then same thing, negative 11 to the 1, negative 11. Keep in mind that the 2/3 power here by the x is not applying to the 6. So that's just 6, not 6 to the 2/3. That's just 2. So I can multiply my 6 times my 2. And then I have x to the 2/3 and x to the 3/4, right? So we'll do a quick adding of fractions, because that's going to be x to the 2/3 plus 3/4, right? Product rule, numbers of the same base, add exponents, okay? So we know it's going to be 12 here, right? So there's my 12. I just need to add those exponents. I just need to add 2/3 plus 3/4. Common denominator. If you have fractions on the quiz, which you will, okay, if they're not going to be super complicated, right? What's the common denominator of 3 and 4? The least common multiple of 3 and 4 is 12, right? I multiply 3 times 4, and that will give me the 12. So I have to multiply the top by the same thing, right? 4 over 4 is 1, so I'm not changing the value. Just a quick review. And 3 times 4 here is 3 over 3, and that's how I add fractions, right? So I've got 4 times 2 is 8 over 12, plus 3 times 3 is 9 over 12. 8 plus 9, we extend the page, is 17, and it's over 12, okay? So my exponent is 17/12. Don't write that. It's true that it's 1 and 5 over 12. That's true, but I'm not going to write my exponent that way, okay? I'm going to write it like that. Just leave it as 17 over 12. I put the last two together on one page. So I've got 2x to the 1/4 to the 4th power. Okay, so that's 2 to the 4th, and x to the 1/4 to the 4th, just applying it. It's not the distributive property, but it does kind of look like the distributive property. It's just multiplication. I'm multiplying, it's just the power. I'm applying the power to each part, right? So anyway, 2 to the 4th is 2 times 2 times 2 times 2. So it's 4 times 4. It looks like it's 16, right? And my power rule, power to a power, says multiply exponents. 4 times 1 over 4 is 1. So it's 16 to the 1, which is just, x to the 1, which is just x. Okay? Over here on the other side, we ended up with negative 8h squared. So again, the 2 and the 4 do not have an exponent. So I'm just going to multiply those. So it's negative 2 times 4. That's the negative 8, and that's where that came from. Right? And then I have the h to the 5th, and the h to the negative 3. So that's h to the 5 minus 3. Product rule. Multiply numbers of the same base. Add exponents. And it seemed like in class today, most people got a hold of this one pretty well. So h squared, right? So you get negative 8h squared. And that's it, right? So, and it's a little bit long on the video side, but I felt like just doing it all in one. Keep in mind your rules. Multiply numbers of the same base. Add exponents. side numbers of the same base. Subtract exponents. Bear in mind, the denominator might have a bigger exponent. Y to the negative 2, so then I've got to put that in the denominator. There's nothing else there, so I got to do the 1. Keep in mind, that's what I mentioned earlier today, the little trick of saying, take the smaller one and subtract it from the larger and leave that variable where it is. So I take the 3 and I subtract it from the 5, and it was in the denominator, and so it's going to stay. And so now it's 1 over y. 5 minus 3 is 2. Get the same answer, and I don't have to deal with the negative exponent. X squared over x squared is x2 minus 2 is x to the 0, but we know any number divided by itself is 1. So any number to the 0 power equals 1. Keep in mind with this, if I had 5x to the 0, that equals 5, right? Not 1, because the 0 applies to the x, the 0 doesn't apply to the 5. So it's 5 times 1, which is 5, which would be very different than 5x to the 0. Now the 0 does apply to the 5 and the x, and so I would get just the 1. We got power to a power, x squared cubed equals x to the 2 times 3 equals x to the 6. Common mistake is that this is x to the 5th. It's not. Remember, that cube means take what's inside, x squared, and multiply it times itself 3 times. That's going to be x2 plus 2 plus 2. Well, we're big boys and girls now, and so when we see 2 plus 2 plus 2, we just write 2 times 3. X to the 2/3. Rational exponents. That is the same as the cube root of x squared. We didn't work with the radicals. The idea of rational exponents is that you don't need to work with the radicals. It makes it so much easier, typically, than doing the radicals. Okay? So, nothing changes with the rules. If I have x to the 2/3 and I cube it, that's going to be x to the 2/3, power to a power, multiply exponents. Let's see, 2/3 times 3. 3's cancel, right? If you want, you could do 2/3 times 3 over 1, 6 over 3. That's going to be 2. This is what I got, what you got here. Okay, and so x squared, right? Okay, well, I hope that helps.